100 or 200% oversizing.
And you won't have to do anything. You just put the age of the building in, and it doesn't matter what you put with it on that. You can put a gas plant on it, you can put an electric boiler, you can put a heat pump, whatever it is you want to do.
Heat source is not so important.
Got me in a lot of trouble, as everyone knows.
Welcome to the UK series. Hello and welcome to our UK series tour. We are currently in London and will record podcast with Rob Berridge. My name is Mario Dodic. I'm heat pump trainer and founder of HVAC Education Hub when we are talking about heat pumps. My guest today is Rob Berridge. Rob is a well-known name in UK industry. He has a lot of experience, a lot of things to chat, so today it will be interesting to chat with Rob. Hi Rob.
Hi,
how's
Mario.
it going?
Oh, very good, Mario. Thank you very much.
Thanks for coming.
Pleasure.
I like your country. We're here a few days in London.
When the sun's shining, it's pretty lovely, isn't it?
And in autumn probably a lot of rain.
Yeah, we do get a lot of rain here, but yeah, it's a different kind of heat here because there's so much moisture in the air. You can feel it, so it's very, very humid.
Yeah,
You get more of a drier heat on the continent.
What is also interesting that we know each other for quite a time, and last year Rob is a heating engineer, but Rob is also bike rider, and he was passing through Croatia and he held really good training for our engineers in Croatia. Rob, did you like?
It was good fun. It was good fun, and it's really good to sort of interact with other engineers dotted around Europe, and you know, everyone's trying to do the same thing. Everyone's chasing that efficiency goal and trying to get as close to the truth as possible with this sort of thing. But yeah, your guys were good, and there's some very, very clever guys there, which was enjoyable and good for me because it puts you on the spot because you don't know. It's unrehearsed, so you don't know what questions you're going to get asked, and that kind of keeps you on your toes, which I quite like.
How you like this training approach? I'm doing trainings. I'm also attending some trainings. You have different people, different perspectives, even different countries. Yeah. I like this part. How you like this conversation, this peer-to-peer learning? Yeah,
peer-to-peer learning is when it's been well proven and well documented that that's the kind of way to do it. I learned the old-fashioned way. I started when I was 16 in 1982.
1982, so more than 40 years?
Yeah, 43 years I think I've been in the industry now. And it was very much peer-to-peer there, but it was very, very strict back in those days. You know, the guy, you got something wrong, you'd like to have a spanner thrown across the room at you or something like that. It was quite brutal back in the day, but you learnt very well from very good engineers. I was fortunate. I found two older guys, sadly not with us anymore, but I found two older guys that were teaching me, and it was a pleasure. It was
just a quick reminder. New online educational heat pump platform is available. It is interactive, mobile friendly, and ready to use from your PC, tablet, or mobile phone. You can find a lot of videos, assessments, and interactive elements. Link is in a description below. What has changed through these years?
Unfortunately, I think we've gone backwards in this apprenticeship. Not many companies can afford to take on apprentices now. It's very, very difficult. I don't think government helps anywhere near what it should do, really, with this. I've been trying. I met actually when I was on my last bike trip a couple of weeks back. I met a really, really fantastic young man, he's only 19 years of age. Wants to get into the industry, but he's written to everybody. He's gone everywhere trying to get an apprenticeship somewhere, and he just can't. He spent like 18 months trying to get somewhere and just can't get anything.
What is the process in the UK? In Croatia, you're just starting to learn, and you're in some companies, but here, this apprenticeship journey is quite good.
Yeah, I mean, you can get a college place fairly easily, I think. I'm not a specialist on that at all, but it's not so much the college, it's getting the practical experience of being on site every day with an experienced engineer that you can learn from. And the problem that we've got in a lot of the colleges and that we have now, even now, is that the tutors, the teachers, they don't really know the industry that well. They'll say to you, 15 millimeter pipe to 2 radiators or to 3 radiators or something along those. They won't do any calculations. They won't do mass flow calculations like we do or anything like that. The good thing is that the private sector like colleagues of mine, like Adam Chapman's done a great course, Heat Geek. Kim Betty's done a brilliant course as well himself with and he's now trying to automate it through a company called Warmer. He's doing that. I've got a brand new course which I'm going to be doing in the next probably 5 to 6 months, something like that.
We are also doing something.
Yeah, you're doing so. So there's a lot of the private sector I think has really kind of taken up, and I think it's good. Sadly, there's still not enough. There's still only a handful of training courses. There's still only a handful of engineers that really grasp the engineering and the mathematics. And the mathematics are really not that hard. I've never understood why more and more people don't get involved with it. But I think it's more than that now. I think it's if I say kids. If young men and women are leaving school and stuff like that, they're going to college. If they say to themselves, "Do I really want to be crawling around people's floorboards and lifting up things and working on a building site in all weathers and stuff, or do I want to sit in a nice warm office?" And I think that's what's happening. I mean, we're not seeing as many practicalities and many practical kind of apprentices coming forward, or many people that want to get involved in the industry for a lot of those reasons. So I think we've got a shortage. We've certainly got a shortage of good people. And I think that's the thing. But I mean, look at what the industry is happening now. What's happening within the industry now? I mean, it's probably one of the most exciting times to be in it.
Yeah, but
100%.
But you said about we are missing. Yeah, I think around 300,000 engineers in the Europe.
Yeah.
How to upskill that? What to do? We are doing something.
Yeah.
We are trying to do something on online platforms. You mentioned Heat Geek.
Yeah.
You mentioned Kimbo. We are all trying, but is it enough? Or we are, as you said, private sector, what I can see also, you learn from the tools, but is it enough?
Yeah.
Or is it enough to share this passion? So you are passionate, I am passionate, but is it enough people who are passionate to push the industry?
Well, it's odd. I mean, everyone's talking about, AI is coming in now and it's taking over, and, people like me as a designer, we're kind of not needed anymore because AI can do it.
Yeah.
But it can't. It can help. It can help. Yeah, it can help. And if you use AI as a bit of a tool, then fine. But I mean, I'm still getting between 3 and 5 calls a day on inquiries for work, and I'm lucky that I can pick and choose now. And I'll only take on self-build projects because people only want to do the project once, so they don't want to scrimp and scrape with anything. I won't work for developers, so I'm lucky in that aspect. But it keeps you so busy that you think, well, where's the time left for doing training or for doing other things like that? But training's a passion, and I think if you can, as a trainer, and I've been doing it for about 5 years now of teaching and stuff like that, which I think is great, and I've enjoyed it. But I've now, I've done my free tutorial course. I'll put that online now for free, so everybody can have it. There's still a load more to do, but as I say, I just haven't had time, and this is the problem. So I'm going to try and make time, and work from one training centre that's likely is going to be in Uxbridge, down near where I live. So it's only 20 minutes drive away from me. But just for convenience for me, I know it's harder for other guys, but I mean, it'll cover all of London and most of the south. It's only about an hour and a half to get to anywhere, something like that, or down to the south coast. So it's there's quite a wide area that we can get, and it's a good training facility down there. We're going to be training all sorts, everything from commissioning heat pumps to gas plant sizing to whatever.
What you are good at the point I also trying to explain, heat source is not so important.
No,
it's at the end.
Yeah,
the heat source is important, and then heat source, whatever you put, and you are the fan of low temperature.
Yeah, massive.
Design.
Yeah, well, I mean, I'm just a fan of efficiency. That's all I want to chase. I'm agnostic about everything else. It's got me in a lot of trouble, as everyone knows, because I can be quite verbal about it, and I like to kind of challenge the status quo.
And you are manufacturer agnostic also.
Yeah. And I think as we move forward, I'm designing everything now at low temperature. So everything at delta T5. So everything at a nice close flow and return temperature. And it doesn't matter what you put with it on that. You can put a gas plant on it. You can put an electric boiler. You can put a heat pump, or whatever it is you want to do. Once you've got it and you future-proofed it, that's what I'm trying to get people to understand and work out on existing systems whether they will run at 4 times the flow rate. Because 9 times out of 10, they will. We all know that at delta T5 you can get about nearly 2 kilowatts out of 15 millimetre pipe.
This is huge.
It's crazy, isn't it? And it's not very, it's mad to think that that's what you could get. But because we've been historically just guessworking everything and oversizing everything. I mean, you think, you know, an average heat loss in a building in the UK is between 6 and 8 kilowatts.
And you have 20 and more kilowatts.
And you've got 22 millimeter primary flow and return pipes and 15 mil to every single radiator. That will easily work on Delta T5 to get that amount of energy down the supply pipe work. So
what is the main thing? I think the main thing is that gas is very forgiving. So you have between 70-90% efficiency more or less with heat pumps from 200 or even less to 500. So bad design will not be.
I think with good design and good design and basic maths, I don't think there's any reason why any heat pump system shouldn't be getting COPs of well over 4.
Yeah, especially in the UK, you don't have you have some problem with humidity.
Yeah, we've got a big problem with humidity, so defrost cycles can be a bit of a pain, and a bit too often, really, I guess, because of the humidity.
And this is what I understand. We talk a lot about oversizing, but let's say in Croatia you have design outdoor temperature somewhere -10. When you don't have humidity. So around 0, you are fine. But in UK, your design outdoor temperature is with highest humidity.
Yeah, 90%. Yeah.
And then, 20% oversizing, it's fine, what we also learned. But 100 or 200% oversizing, what we can see.
It's about, I mean, we've had this conversation, I think, a few times in the industry now. It's a compressor, if you like, on a heat pump is exactly the same as a car engine. All the damage is done on the very first start up in the morning. Once it's warm and it's all up to temperature and it's running, you can start it up quite a few times and it won't cause so many problems. But if you're letting a system heat up, cool down, heat up, cool down, those compressors are not going to last very long. So oversizing is not so much of a problem with the heat pumps because it's keeping the compressor warm. And that's the thing, as long as that compressor is nice and warm, you've got less wear on it. But I mean, you still want to be trying to maximise the run times of it, surely.
Not to, like with, as you said, with the engine. You don't want to start-stop
you
a lot of times.
Get it into top gear and then just cruise, just nice, 40, 50 mile an hour down the motorway. You're going to get the maximum amount of efficiency out of that engine. Same thing with a heat pump or a heating system. Get it down to that simmer point. You boiled it up and you're just simmering it and just keeping it, using the least amount of energy just to keep it going. Yeah,
and it's hard to explain to customers also that you will spend less money and less energy if you leave your system, as you are also a fan of that. Just leave and system will take care not to turn off. We are talking a lot about residential, but in commercial buildings, people are turning off when you have really high capacities and you spend even more energy if you turn off the system, cool down the building. And then you have this problem.
I think again, it's the kind of low, long, and slow attitude, isn't it? You can keep something ticking over, nice and slow. It's much more efficient. I mean, anything that is stop-start. I remember using this analogy years ago. You think of a very heavy truck on a motorway, a busy motorway, and lots of traffic. If it's stop-start, it's really not efficient at all. Where it's just on and off, you're just using up gallons and gallons of fuel that you wouldn't need to do so. Whereas if it's empty and you're just cruising along down there, it's the maximum amount that you're going to get out of it. And so intermittent heating doesn't really lend itself to kind of vapor compression technology or to heat pump technology. Sadly, whereas with gas plant, it did, but only because gas is so forgiving. But you're still going to have pre and post purge of a gas valve and the fan, because that's why sometimes when you see a boiler cycling, you go past it, you get a real strong smell of gas, where it's you got the pre and post purge. So that's the waste that's going into the atmosphere and God knows what. So that's not efficient at all. So it is running that long slow. But again, with gas boilers, turn down ratio is not very good. You can get some now that are down to about 2 kilowatts, but if you got a house that's like 4.5 kilowatts, which is mine is,
it's always
that turn down ratio is still too big. You need it down. You need a burner down to 200 watts or something. Silly like that.
What I think is the main issue, because heat pump is much more expensive, compressor is much more expensive. So gas valve is a few €100. Okay, we are fine. Compressor is €1,000, and if you want to replace compressor, you need a refrigerant guy. It's huge amount of money, and this is why also this system needs to be really good design on them.
100%. I think the further we get down the road of low temperature heating, the more technologically advanced it's going to need to be. I mean, I'd say I'm designing everything now really open loop, so there's really not a lot of resistance.
What is open loop?
Open loop is basically the minimum amount of resistance that you can get within a system. So all parts are all joined up together, and it's controlled primarily by compensation controllers.
And how about, let's say we have here some heat gains. How about heat gains?
Right, well again, I would generally only be putting in thermostatic control on rooms that are going to get solar gain. And then the rest of it, have it all on open loop and just have it on a load compensation controller with weather compensation as well. I mean, ideally you get both of them is the great thing. But as long as I prefer load compensation. It's just my own personal opinion. I prefer load compensation because it's measuring the heat loss of the building constantly and in real time. Whereas weather comp is using outside data, and it uses local weather station data, all sorts of things like that within the control system of the units.
So weather compensation only to control water temperature. So when it's hotter, you have different temperature, and load like as a main thermostat. But this is also, let's say, what is thermostat? It's not like people used to have just turn around, on and off.
That's just an on-off.
Yeah,
on-off
we need modulation.
You need that modulation. You need to be able to, and certainly. You know, I mean, I remember back when we started trying to do this, is sort of 6-7 years ago, and we were all beginning to kind of talk about it a bit more, maybe a bit longer than that now. Was people trying to design heating systems at 25-degree flow temperature and succeeding? You know, as long as you've got enough system water volume, you can do it.
This is hard to explain because we said, okay, we want 20 degrees inside, but we need to move water from point A to point B as smoothly as we can with less energy that we have. So as you said, with 25 you can still heat up the room if you have system volume and if your emitter is good enough.
But this is the whole thing. It's technically, if you want to heat a room to 21 degrees, you only really need 21 degrees flow temperature. Technically that's what you could do because of the second law of thermodynamics. Hot will always go to cold. But what I find interesting is that there's kind of two things that you can't oversize in a heating system, in my opinion now. One is expansion, which is a big subject on its own. The other is water volume. You can't oversize radiators, you know, because as long as you've got good modulation control, and when you think about, you know, the specific heat capacity of water is really quite high. So yeah, it's hard to get it up to temperature, but once it's up to temperature, it holds its temperature really, really well. So easy to transport. So once it's up to that temperature, you can just literally just roll it around, just let it go and let it go and let it go. And then just slowly modulate setback. So if you've got 3 degrees setback at night, which is what I would do, from 21 down to 18 or something.
And probably almost never you will have that if you have
exactly that. And you know, you can use that if you're using a buffer on commercials or whatever it is, you can use that for all your defrost cycles. And there's a way of, I'm pretty sure, I'm not seeing. A lot of the data that I'm doing now with heat pumps that we're installing now, I'm trying to see if we can get them running between sort of like 20 and 23 hours in every 24-hour period, which is the gold, isn't it? If you can get it down to that, you know, less than 4 startups during a day. Can you imagine if you could get that? That would be, you know, you'd be up in the 600% efficiencies, wouldn't you?
Especially
maybe
in the UK,
more.
You have really warm weather. And what is the sweet spot for system volume? We are talking a lot about system volume. We have some data for heat pump monitor, and you have some data. What is the sweet spot? What is the minimum?
It depends.
The minimum.
It depends on what your flow temperature is. So the lower your flow temperature, the more volume that you need, and that goes so. But it is linear. And I've calculated it out. I've got some charts, and I've already put some charts up on my site.
Yeah, with radiators, with radiator data.
Yeah, that's
you put correlation.
Yeah. So you can work it out fairly easily, but you know, certainly minimum you want is around sort of 17 litres per kilowatt, ideally, which sounds quite a lot. And you know, people saying, I mean, there's different manufacturers. I'm going to see a manufacturer just after installer show this week. Going to see a manufacturer on some new underfloor heating spec that they do, and they reckon there's a 40% gain in heat transfer with their particular coils that they use. Now that's a massive saving. If that's a 40% gain, that might mean you can actually reduce the flow temperature by about 40% as well.
Yeah.
So to get the same sort of output.
Of course.
And of course, because of that gain, you need less material going under the ground. So that is less water volume. So what I want to do is work out with that, when I see the heat transfer coefficients of that might be down to say 7 litres per kilowatt is all that's needed, or whatever. I don't know what it's going to be yet, but this is what I find really interesting about how it's going to move forward, because as I say, once that water has been heated up to the temperature that you want it, it doesn't take loads and loads of energy to keep it there.
Yeah, you're just leaving that low and slow, and just you're not heating up whole amount.
Well, yeah,
you have thermal mass. You have thermal mass
you got all the mass in the building as well.
We have what is also important. We have static conditions when we calculate. We have some recommendations, softwares, and so on. But these are static conditions. We live in dynamic world. We have thermal mass. We have ventilation rates, which is filled for itself. This is what I think where we are failing. With this, of course, we know that from experience. And we have proven that. But this is hard to explain to someone who will say, okay, we need to oversize a lot because our standard condition is this and that. In reality, you don't need it.
No, correct. I mean, it's, if your heat loss calculation is accurate, and let's just say you've got 4 kilowatts of heat loss, that's 4,000 joules per second that is leaving that building. That's in energy terms.
In design out
and that's what I call it ODT. Some people call it design outside temperature or DOT or whatever. But we all know what it means. But 9 times out of 10 in the UK, because we live in a temperate climate and we're on the Gulf Stream, it's around. It never gets down to ODT. It's 9 for maybe 2 or 3 weeks of the year. It's not that much.
And
normally it's around,
always at the night.
When you
don't have maybe.
You don't have it on as much. So it's like about 7 degrees outside or something along those lines. So your load is completely. You can drop that temperature right the way down as far as I can see, as long as you've got enough mass going into the building. I mean, I've done my calcs based on a standard 21 degree room temperature, and worked out from that. But once I move into this and I delve into this a little bit more, I'll do it per different degrees, 18 degrees and all sorts of things like that, and build something along those lines. But that's, to my mind, that's where it kind of needs to go in terms of not overcomplicating design, not overcomplicating all the heat loss calculations. I mean, you can do a heat loss, an overall house heat loss calculation just from a previous utility bill.
If you have it correct. With gas it's fine, but I realize with oil, with some things.
That's a bit harder.
It's harder, not because of the consumption. You can calculate kilowatt hours, but usually you're spending more than you need.
Yes, correct.
But if you have correct gas.
If you've got correct gas data, then it's really accurate because it's telling you exactly what you're using, and it's only energy divided by time, so it's really easy to do. And
what I realize is the best if you have good gas data, you have heat loss calculation, which you can do. You have some experience, and you are attacking it from a few different sides, and then you are sure you need, I don't know, 5 kilowatt or not 10 kilowatt.
Look, for regulation and stuff like that, you need
what
to.
What is about regulation?
Well, you need to have a room by room heat loss calculation done, and as long as it's done.
This is regulation.
It's regulation in the UK now, Okay, so any upgrade or anything like that.
So now. Only for MCS or generally?
No, for building regs now as well. For building regs. I think it's Part L building regs 2021. But I think now, and why wouldn't you want to? Why wouldn't you want to know how much that room is requiring?
In Croatia, we are not doing so much of this on it. It's like guessing.
See, that's the thing.
But it's hard to explain to people. Okay, you will pay this heat loss, whatever it costs. But you will spend less because you will know what exactly. It's not 5 kilowatt or 10 or 15. But I realize in UK everyone is doing. But this is now it's understandable because you have building regs, which is quite good if you ask me.
I mean. The way I look at it is, you've got EN 12831 standard is a good standard. It's going to take, I think, decades for this to really take on, and for every single engineer to be sizing correctly, because they're not at the moment, and no one is, and there's still a lot of guesswork that goes on. But I think I think the regulation actually states that you've got to be able to match the heat source to the heat loss of the building. I think that's what it is, but they are asking for room by room, and certainly Offtech are asking for it now with anything that they do, and I just think it's just a bit more accurate. You're going to get a lot better run times and a lot more suitability within the system. So I personally think it's a good idea, and there's so much software out there now that can do it very quickly. So
and also what I wanted to ask you, we are talking about this software thing and AI. So AI can help us. Software can help us. But what is the good sentence? Garbage in, garbage out.
Garbage in, you're only as good. everyone can see a calculator and use it, but if you don't know what numbers to put in, it's just going to come out with gobbledygook, isn't it? It's as simple as that.
Yeah, we had one example. I have a video where house which is 10 kilowatt in project in design was 30 kilowatt.
Yeah.
And you are breaking building regulation in Croatia for new builds, because for new builds you need to have nearly zero energy building and this and that. And if you are doing new build in Croatia, you cannot have more than 50 or 60 watts per square meter in Zagreb.
Right.
This house has more than 100. What is the point? The point is that this was design office, and the point is that you need to know what you can expect from software. We did some project with high heat loss, and we realized that we didn't define windows.
No.
We have just hole in the wall. But you need to know that. Software will not tell you.
No, it won't tell you exactly that. I think as it evolves, and people are becoming more and more savvy to building these sort of software and things like that, it's going to evolve quite quickly. And I think that certainly within the next couple of years, it's a full room by room. You'll be able to walk around with the LiDAR technology and all this kind of stuff like that, and you won't have to do anything. You just put the age of the building in. It will assume a certain amount, which is fair enough. And look, you can get too kind of under the microscope with this whole thing, really. All we're trying to do is get a little bit closer to the truth. We're just trying to make it more efficient. I've always said that we know that it doesn't really matter so much now in terms of compressor longevity and that if you oversize a heat pump to around 20%, doesn't matter too much. But you find a lot of countries that are using heat pumps, like Scandinavian countries and stuff like that, they only size to about between 70 and 80% of the heat load.
Is this a sweet spot?
Yeah,
sweet spot, I think.
And then the system's working, hard. It's during its time, but you're getting very, very high COPs coming back out of it. And then for the 1 month of the year that it does get a little bit, they get 3 foot deep in snow or a metre deep in snow up there, they'll bring a log burner out and they'll use that for that top up. So, and that's just that works for them. And I don't know. I mean, it's not ideal for the whole of the UK because it's too populated to do that. But in terms of, I still think there's room. I still think there's room for hybrids. I still think there's room for all sorts, depending on the building, depending on what is going on. I mean, I've just started doing some work now with the Church of England, and the Church of England have got they've got illusions, frankly, of what they're going to do with very, very leaky buildings like big old churches that are 16th century. They don't really lend themselves to intermittent heating, and heat pumps don't really lend themselves to intermittent heating themselves. So we've said that to them. We've said, look, we can think up things like secondary glazing and all of those sort of things to try and get some of this low-hanging fruit out of the way, so we've got a much more of an airtight building, and do that. But you do realise it will cost you probably less to leave the units running than it would be just to try and heat it up. And you just want to have a setback temperature and keep it at that temperature, so you raise it up for your Sunday morning worships and that sort of thing like that. But it's all about changing the mindset of how they work. And of course, the other option that you've got is to put VRF systems in, isn't it? Of using like air to air cooling. But it's getting the refrigerant in commercial properties, because they banned, was it 410, haven't they? That's gone.
410A from this year it's banned.
It's banned.
32 is here, but Europe is going into the direction of water.
Is it?
Water, R290.
Right, okay.
Will be the main thing, I think, and the water will be. Yeah. I'm not big fan of cooling with water, because it's not work, but because you need to really take care of design, of condensation, of cold water. Yeah. Because with heating, you'll spend more money, but you can heat up. With cooling, it's not forgiving. No, it's not forgiving, and this is. But you mentioned church. It's quite interesting. We are focusing, my focus is mostly on residential. We are focusing with heat pumps, but there are a lot of other things. Churches, commercial buildings. We are doing also some commercials where you can easily have payback period really fast, because you are spending more and with high efficiency.
But this is why I was saying that there's room here for hybrid. So you can use the gas back up to bring the buildings up to temperature quite quickly. And then once it's up there, then use the heat pumps just to simmer it and simmer it along. The efficiency gains are going to be huge, over 80% of what they've got now, savings from what they have now. And that, to my mind, is a no-brainer. And that's why I'm not a die-hard heat pump designer or specifier or anything like that. I'm just completely agnostic, and I think I need to be, in order to try and give the clients the best answers and the most honest answers that I can do.
How can you see the complete industry today? So we talk about passionate guys. We are here. We are trying to make these things, but a lot of things are changing. We have heating industry is different because you have energy suppliers here, and we are talking about efficiency, about COP. That's fine, but we have completely different energy system. We have photovoltaic, so PV, cars, batteries, storages, so phase change materials, different kind of things. If you will have cheap electricity, it doesn't matter if you run up higher. At some point, I don't want to say that good design is really important, but people want to pay less money.
Good design will always be important in my opinion.
Course.
I don't think that's it. And I think that being in the heating industry, certainly in a country that always is, it rains all the time and it's generally cold all the time, apart from today, obviously it's not. We're always going to need engineers. You can't. No amount of AI or robots or anything like that are going to be able to do our job. It's as simple as that. So I think the industry's safe in that terms. In terms of, like, from my perspective in design, who knows? AI might take over. What I don't know. Frankly, I'm too old now to care really. So I'm not. It doesn't worry me. But I think with people coming into the industry now and the way that the industry is going, it's going to get a lot more automated. It's going to be a lot easier, I think, to get the right design for any type of building that you want to do. I think with the LiDAR technology, there's going to be people at underfloor heating companies and that sort of thing, manufacturers. You'll go in there with a LiDAR scanner and it'll go, right, boom, what's the heat loss of the room, boom, and it'll just do you a...
Even you don't need to go. Maybe homeowner can just do it.
Homeowner can do it. Yeah.
Thank you.
Yeah, exactly that. Yeah, email it to this. Job done.
Because it's really time-consuming job.
It is. I think most people now, if you're going to go and do a domestic property, now most designers and stuff, they're charging around sort of 300, 350 quid for a heat loss calculation done on their house. I mean, that's quite a lot of money.
Yeah, but you spend a lot of time.
Yeah, but you do spend quite a lot of time on there. So it's the designers that are going around and doing good jobs and good due diligence in their jobs. But it's I think that process is just going to get quicker and quicker and quicker. And if it does, obviously there'll be much more take up on it, which means we're going to get much more accurate installations of systems, which hopefully means we're going to get much more longevity out of systems, and start winning back the public's trust. Because so I'm not sure what Croatia's like, but in the UK, plumbers and builders and the allied trades in general are not held in very high esteem.
But why?
Because it's always been the cowboys or let's do a job cheap quickly and do it for cash or do it for. It's always been that kind of do it quick and what I found really strange, the British public actually see heating as an inconvenient necessity. They don't like the fact they want it to work, and they don't want to service their boilers, they don't want to service their heating systems or anything like that. But as soon as it goes wrong, it's this is no good, that's rubbish.
But after food and drink, it's the most important thing.
Well, 100%, yeah, 100%. You go to Germany, places like Germany, and they're taking you downstairs to show you their plant room because they're so proud of their heating systems and they look after it. I mean, I had some properties in Germany which I've sold now, which has kind of facilitated my sort of semi-retirement really. But I had some properties over there, and one was built in 1954, just after the war. And that building, they were working on VDI 2035 then. That building had exactly the same original heating system. It had the same boiler in there from 1954. All they'd done was they took the oil burner out and put a gas burner in. All right, and that was feeding 14 properties 24 properties in the building, and that never ever had a bit of chemical in that in its life. And every 3 months they'd go out, the engineers would go out, take water sampling quality or water quality samples, and then they would probably replace maybe 25% of the water within the system, that sort of thing, and keep it with demineralised water, that sort of. And it's like all that time, that longevity, same pipe work, same radiators, same valves. I mean, it's just incredible, and I couldn't believe it. I was just lucky. I was lucky enough to be there one day when they turned up, and I asked the guy, and he spoke really good English, which was kind of helpful for me because my German's terrible. And he explained it all through to me, what they were doing, and that was it. I was hooked and just sold by the whole idea. And so now, when this training starts up, we're now going to work with Elector, Simon Douthwaite, and he's got another company called Gemtex. We're going to work with them at getting water quality as part of a training session. And
I'm not the expert, but you know quite good about that. And you said the cheapest thing in the system, but we have the most trouble with it. What is with these chemicals with water?
Well, with chemical VDI, BS 7593, I think it is. BS 7593 states that you must put inhibitor into a heating system to stop corrosion. But I've got some good friends in the business here now. Ricky from Thorough Flush. He's been fighting this long uphill battle for a long time, because nobody tells you exactly what the dosage is, and sort of the manufacturers don't even know what the dosage is. It just literally says on the bottle sometimes overdosing does not present a problem. Well, we've proven that it does present a problem, and you
have a lot of different things. So it's not you have corrosion and you have scale, but you have a lot of different things in the water which could cause a problem.
Yes,
and then you take care of everything, of conductivity.
This is the thing, and also, I mean, this is a massive subject. But expansion, people getting expansion wrong, especially on low temp systems. And if you haven't set that expansion vessel up properly and it hasn't got the right amount of volume in it, you can get oxygen ingress. So through any fittings or any plastic pipe that's on the system or something like that, it ingresses oxygen.
And then you have corrosion.
And then you've got corrosion. Oxygen is the biggest cause. Oxidization. It's the biggest cause of problems. It's the biggest cause of health issues in us. It's all sorts of things like that. So we really do need to kind of address this. And as we've said, water is the cheapest component in the system, but it's the one that gives us all the problems.
And we mentioned a lot of things, and what I can see that heating engineer needs to be quite good in a lot of different fields.
Yeah.
It is quite hard, especially today when we are talking about battery storages, PV, time of use tariffs. So you need to be kind of a software guy.
Yes.
Still, you need to know pipes, mats. If you want to be a good service engineer, I think this is the hardest job, because you need to understand everything.
Well, that's my Achilles heel, because I'm lucky. I'm sort of, I'm nearly 60 years old now, and I don't need to work so much. But I'm just a hydronics engineer. That's all I do. I'm just a glorified plumber at the end of the day. And I've served my time as a commercial and domestic gas engineer. I got into design work over 15 years ago now, and love it. I love it. And what I find strange, really, more than anything else, is that I didn't take up the knowledge and learning the major knowledge bits on controls, and that's what I wish I had done more of. Because all I do now, I've got a really good controls guy that I use, but I just tell them what I want something to do, and they'll design it for me for that. And then when I'm there on site commissioning as the professional witness at the end of the job, I just make sure I've got this checklist that I go through and make sure that's all set up correctly. All of the curves are set up correctly, and the flow temperature is set up correctly, all those sorts of things, and the pump speeds are set up correctly, obviously, from the index circuits.
What about this topic? You mentioned also quite a few times we are talking about oversizing heat pumps, but oversizing pumps, I talked with some pump manufacturers. They said that almost every pump is oversized, and you have some data which is how many percent?
No, it's horrendous. It's and this is not something I made up. This comes from one of the top hydronics guys at IMI Hydronics. He brought this up, and he said that they did a survey on commercial systems, or any type of system really, and it's between 15 and 20% of the world's entire electrical energy is taken up by dead-headed and oversized pumps, which is, and it's trillions and trillions of euros, isn't it? Or trillions of dollars, or whatever it is that's an inordinate amount of waste, and that's why I've always said #wastage crisis and not anything else, because it's because people don't know how to set it up. People don't understand what a 1550 pump is, and that's
size the pump by the size of the building. But it's quite a good question. I think a lot of people are not thinking about that. In reality, you also gain some insights and change my view on our training last year. that you can feed your system with really small pump.
Yeah, you can. Yeah.
You can, especially also retrofits. But you said almost every retrofit, even in Croatia, you have really good pipes, 22, 28 millimeters.
Yeah.
So 28 is approximately 10 kilowatt.
Yeah.
You don't have such a high heat loss here in UK. No, but even in Croatia.
Well, this is why I'm designing a lot of most of the domestic heat pumps that I'm doing at the moment. I'm just doing one at the moment now. I'm designing it completely 100% open loop, so it's one pipe system. So it's all one pipe. Because you're DT5, you don't need to start making radiators at the end of the line much bigger. Okay. But I'm doing it on the system water volume anyway, on my own process of doing that, and they run like a dream because there's no resistance running right the way through it. You're allowing. What I do insist on doing though is piping the radiators up as you guys pipe them up, so TBOE, so flow in the top and return out the bottom, even on a one pipe system. And then obviously the flow coming in from that end, if you like, that's where the highest input is into the radiator, and you're just using the second law of thermodynamics in order to make that work, and it just runs so fantastically lovely.
And you don't need big pumps for that.
You don't need hardly anything. There's just hardly any resistance.
Separation.
Yeah.
What about buffers and separation? It's also quite a huge topic, but
if you don't have lots of water volume and you can't get it into the radiators, then yes.
But on return, like a volumizer.
Yeah. Well, you could use a volumizer, but then you only really want the volumizer just for defrost, really. Nothing. And it's just because of the unique weather of the UK being so humid that this is where we have the problems with the defrosting, I think. And we talked about this. I did a podcast a little while back with Mars from Renewable Heating Hub. We were discussing this with a good friend of mine, Ken Bone. He's a very, very clever engineer, and we were talking about the very careful positioning of heat pumps in the UK. If you put a heat pump on a north face of a building, you're more likely to have more defrosts going through to it because of the moisture, and it's cold, and that moisture. So if you can get it on the south side of a building, your compressor's going to stay warmer for starters. You're going to get less startup times because the compressor won't be sitting in such a damp environment, forming lots of ice. So it was a real interesting conversation of what we could do, and I think it's a thought. It's good that the government have now just said, okay, this boundary rule is now scrapped.
They're changing.
They're changing. Not scrapped, but changing. I don't know what the full wording is on it just yet, but that's a really good move forward, and it's going to allow more people to do. Certainly when my gas boiler is done. And it's become beyond economical repair, I've got a perfect position for a little 4.5 kilowatt heat pump or 5 kilowatt heat pump at my house, which would be fine, and it's right in the direct line of the sun. So it's I'm going to get minimum amount of downtime of defrost basically, or hopefully, because even on a winter's day, if the sun's out, it makes it a lot less humid. In terms of that. So
What about collaboration and peer-to-peer? I like this. Maybe the most important thing for me. We now work together with Ian Edgeworth on the book.
Yep.
With few collaborators, and let's say I'm making videos, you're making some designs. What is your opinion? I think this is the best way to share and to scale all of these things.
Yeah,
to help each other and to help community.
Collaboration's a really good thing, and as I say, certainly with some AI now, I was anti-AI for quite some time, and I think a colleague of mine, Patrick, he put me right on it, and he said don't think of it like that. Think of it as just a tool.
Yeah, it's just
it's just a tool, and don't just think of it along those lines. So I've actually started using it, and I've used it to write certain sections of things that I've done, and then when I read through it, I take that line out and put my own bit in or whatever it is, and so it reads like it's from me, and do it that way. And it's because it's coming up sometimes with some ideas that you either forgotten about, or you just at that moment you can't bring your mind to it, and
concept is.
So I found it quite useful. So we'll see how it moves forward. But yeah, I enjoyed. I wrote all of that in that book. I enjoyed doing that, and I say index circuits. What got me about index circuits is that you can search on the internet for index circuits, and there's nothing out there. There's no tutorials. There's nothing.
What is index circuit for listeners who are not?
Right,
I'm so familiar.
An index circuit is basically, it's a valve or a length of pipe or whatever it is within a circuit on a system. You might have multiple circuits. So an index circuit is the one that has got the most amount of resistance to flow. So it could be a radiator valve, it could be a PIC valve, it could be any kind of other thing like that, or it could be a length of pipe work further way down the fitting. As if you're measuring out the resistance all the way down a circuit, whichever one of those circuits within a building has got the highest resistance, that's your index circuit. And so that pump, if you size your pump to the pressure loss of the index circuit, it doesn't matter if you've got 2 radiators or 200 radiators or 2,000 radiators. As long as you found out what the index circuit is, and you get over that, it will get over every single thing else. Everyone seems to think you've got to add all the circuits together, and that's why you get all these pumps that...
Yeah, pump and pump.
Exactly that. Well, I gave you that example, didn't I, of the project that we did in Hitching. It's 238 flats up there, and they had it was DN 150 pipework coming off, so so big size pipework coming off, and they had these 2 huge pumps in there, fixed speed inverter pumps in there, and it was costing them like £1,000 a month to just for the electricity to run these pumps, because they were just flat out, and you could see the velocity in this pipework. I mean, it was really well clipped, but you're talking really heavy steel pipework. It was shaking around like crazy with the velocity of the water going through these pipes. Of course, that's causing all system erosion, corrosion, all sorts of stuff, component failure, and all sorts of things. I sized the pumps and I got it, and I couldn't believe it when I saw the ones that I took out. I mean, I could barely get my arms around the inverters. But when we put the new ones in there, I mean, they were tiny. They were like this sort of size. Now it's running perfect at DT10, and it's just running sweet as a nut, and it's probably around £150 a month in electricity to run them.
So math and understanding what we are doing.
Well, yeah, I mean, we saved them on that project. We must have saved them over £100,000 in pump supply only. That's
not
crazy.
bad.
Yeah, it's very good. Yeah, especially I only charge hourly rates, so I should have charged a percentage.
Yeah, but, just percentage. Yeah.
Yeah, but it's this is the thing, and it's not hard to do. There's so much stuff. Say, my videos are for free, and I've done. I think it's a fairly good one on index circuits. But you guys, you tell me whether you think it's any good or not.
Yeah,
but,
it's fine.
It's a subject that everybody should understand, but doesn't.
But how you can see, let's say we are now making some platform like online educational with interactive tools. We have in-person learning. You have some videos. You have some really good concepts. Guys, they write the books. So not every person is the same. Someone can educate himself better with books. Someone is good with animation.
Yep.
What is your view? I think this mixture is really good.
I think the mixture is good. What I've noticed, because I've done since I stopped teaching last year, and I'm obviously in between sort of building new training courses and stuff like that now. What I've noticed is that there's any of these tutorials and things like that are online. It's not anywhere near as good as being face to face. So in a classroom, person to person, people you can. What I mean is you can get the nuances of people's faces. You can see if they're struggling in a classroom. You can see if they need a bit more help or something like that. Whereas if it's online, yes, they can rewind and go back, but you'll find that a lot of people, if they can't get it the first couple of times, they'll just flick off. Whereas if I'm in a classroom with somebody and maybe they've not understood the way I've explained it, I can sit down with them and I can just try and explain it a different way until the penny does drop. And for me, there's not much of a better feeling than that, because if the penny drops and you see the veil come off.
This is rewarding.
Face, yeah. Oh, really rewarding, yeah.
Really rewarding.
Yeah.
But still, with online, let's say I meet you, you meet me. So it's really good to have this tool. Not maybe like primarily tools, but you can scale. You can go from Croatia to UK with online.
Yeah,
in person is always in person. I like this also.
Yeah, I mean, I've made a mistake at the minute. I've taken on way too much work. And I'm struggling to keep up with it now, which is why I haven't been able to do some of the online tutorials and some of the other stuff. I've got editing to do, even from a motorbike trips. I've still got loads of editing to do, so I haven't had time to do it. So it's my fault. I said I was going to slow down. I didn't. I speeded up. So I'm an idiot. But there we go. That's it. But no, it's once all of this work that's going on at the minute is done, I'll get this course rigged up, and then I think what I'm going to do then is have people in the class, give them maybe 3 months. after they've done the training, and then maybe do with everybody, do an evening, 1 hour, and we'll just go over the questions on an online meeting, just to kind of do like a refresher, because what you don't use you lose, obviously.
Yeah, and learning pyramid is always
exactly
when
that.
you are teaching, when you are here in the loop, you are good.
Yeah.
After a few days, it's really decreasing.
Well, I mean, you'll see like a lot of people, like for argument's sake, Adam's course is a good course. That's peer-to-peer, so you can actually go around and you can speak to people while you're doing it. It's not in person, which I think would be better if they could do that in person.
It's hard to scale.
It's hard to scale, I know. Yeah, Kim's one that he does. I mean, Kim's brilliant. We all know he's great. You're finding a lot of people though are going back to these courses, mine included, and going back again and again and again.
The same course.
Yeah, same course.
Just after some time, just to refresh the knowledge.
Refresh and come and do it again.
Different perspective.
Yeah, and I think this is the thing, and this is what I just try to say to people. I mean, we all know that we've got various apps now for calculating pressure losses and pipes and pipe sizing and all sorts of stuff like that, which is good. And I use one particular one, the IMI one. I use that every day.
It's very good.
Yeah, I use it every day. Danfoss have got one as well. It's not too bad. But there's more and more coming out there of this sort of thing. So I think it's worth having. But unless you're using that all the time, you forget. Yeah. And you can't blame engineers for this, because it's hard out there. It's hard for engineers to do.
A lot of things are going on.
God, man, I think, would I get back into the industry again if I was 16? Would I go, right, I'm going to get...
this is what I want to ask you.
What
will you advise?
do you know what? I don't know. I think I would. I think I would, but I had between sort of 5 and 9 guys working for me for just over 20 years, 24 years, and that was hard. That was hard. We came back from travelling. My wife and I, we came back in the end of 2001, and from being away for a year of travelling, and we just thought, right, okay, let's just get down into work. So we did nearly 6.5 years, almost 7 days a week. At that point, very, very hard. But managing all those guys as well, and being responsible for, sometimes 9 mortgages and plus your own. It's a lot of money you've got to try and find. So from the stress of it was hard. So I used to do all the plant rooms, basically. I wasn't the guy that was doing all of the chasing up floorboards and the running a pipe work through that. I had younger guys that were doing that, because frankly it is a young man's job. It's hard. It's very, very hard work. And I think by the time you're I don't know, 35 to 40 years of age, if you're still on your knees every single day, you're in trouble. You need to be getting on. I was lucky, touch wood, with what happened to me, and I could get into design and stuff like that. But it's a very, very difficult and very hard game to get into. So I think if I was going to get back into it again now, I think I'd probably go straight into commercial. I think I'd get straight into the commercial side of things, because even though it can be harder work, it's not as you're not kneeling down in front of a hot water cylinder cupboard all day long. Put it that way, trying to pipe it up and that sort of thing, and getting really damaged. I mean, now I go running now. I've got hairs on my knees for the first time in 40 years. 50 years. Whatever.
So your advice will be to look more. Let's say today software, and we have a lot of these IT guys. So we have Mick Wall, which is a homeowner. They understand how system works because they are good with data. And I think tomorrow or today, engineers will more be like this kind of, let's say, all-rounder.
Yes.
Of course, you need to have someone who will put the pipes and so on. But to understand all of these things, it will be really interesting work.
100%.
We'll be back in a conversation in a few seconds. Just one reminder. We launched a new online educational platform, Heat Pump Bootcamp. You can learn at your own pace on your PC, mobile phone or tablet. You will find a lot of interesting videos, assessments, interaction and quizzes. Feel free to reach out and to check. Link is in the description below. I
think, there's going to be more and more designers coming out there, which is really good, because there literally isn't enough. And I know I'm talking myself out of work here, but I don't care. I'm slowing down now.
300,000 people missing in Europe. This is
that's huge.
Part of official data. Let's say it's huge amount.
That's huge amount. Yeah, it is a huge amount. But I mean, I set up a website. I've got a company to build me a website. many years ago. I don't really do much maintenance on it now. I'll add a few projects from time to time that's on it. But you type in heating design consultant on any search stage, and I'm number one. I'm still on page 1, and I can't believe that. So there's really not enough people doing it. And if I can do it, anyone can do it. You know, it's not that hard. You know, do things like, you know, do the Heat Geek course, do Kim's course, look at my tutorials and stuff like that. And if you get that, you can do it. Anyone can go in and do design work. Yes, you've got to go and learn CAD software and all that kind of stuff.
But you need to want to learn. This is the main thing.
Yeah, you do.
It's really hard. People think, okay, we have a job and that's it. But I am learning a lot of time. You are learning.
Yeah, I mean,
you need to learn.
You got some outlays as well, because I mean, I don't know what I spent probably about £3,000 or £4,000 ago on getting all the regulations and you know, downloading the regulations and joining various different organisations and that sort of thing.
But you learn a lot of things.
Yeah, you do. You do learn all of those, and you know, it's writing a tender document is very difficult. I mean, I spent probably 30 years writing mine, you know, and that's just through experience and God knows what, but. Yeah, and it's mine. Although a lot of it is generic, mine's probably, I don't know, 140 pages long. You know, and then you do all your specific calculations on top of that, and so you've got to get all the insurances in place for whoever the contractor is before it goes out to tender. And it's a legally binding document, and it's not something you can buy off the shelf.
Yeah.
So this is the problem. So if anybody does want to get into design work, that's what you've got to cover yourself for. You know, another expense that I have to do. I have to have £10 million worth of professional indemnity insurance.
Yeah, you need to have that.
And that's £10 million per project. So if it's a commercial project, so it's there's some policies out there that can do that. So you know, you've got to think about what the overheads are. It's professional indemnity is not as much as public liability is, because you're talking about a design flaw, not anything else, and a lot of that you can offset through manufacturers anyway, because your manufacturers are taking on that responsibility for what they've done from the designs.
Yeah, but still I think designer must be responsible, because manufacturer just recommendation. You need to understand what is doing it.
Well, I think the thing is that, you know, as they say when you're doing your gas qualifications, and they really drum it home to you these days, is that the UK is heading more and more towards what the US is looking like. You know, we're kind of almost like, you know, a pseudo United States, but it's become very litigious. So anybody that thinks that they can think you've made a small error in design or whatever it is like that, they will try and come for you if they think they can get some money from you or whatever it is. So the whole point of this and getting into this idea is to cover your backside, basically. Make sure you've got everything in place that's going to look after you in the event of something that's happened. Now, you know, in 43 years, this is going to sound like the kiss of death now, isn't it? But in 43 years, I've never ever had one claim against me. So, I'd make sure that I'm so what's the word I'm looking for? Yeah, well, I'm everything with a fine microscope, you know, just to make sure that I crossed every T and dotted every I. And my wife's also very good at reading through these things, you know, when she prints these out for us and that, but because we work as a team. But but I would say to anybody that wants to get into the industry to do that, or you know, you're thinking to yourself, look, your knees are starting to hurt now, and you're coming out, but you've got really good knowledge on system design. Come out and start thinking about design work, because, you know, I mean, frankly, the way it is at the minute, I can probably pass quite a lot of work your way.
Yeah. And what is your, let's say, we are near the end, the final message? We are also speaking, and you are also in contact with a lot of different manufacturers. We have a lot of different things here: heat pumps, valves, pumps, so on. Industry is changing quite fast. What will be the message? Let's say people think usually, okay, some manufacturer is doing something, but they're all people like you and me. So I want to say we blame society, but we are society. Yeah. We are these manufacturers. We are these guys. What will be your advice after more than 40 years? How to approach these things, how to spread the message or the knowledge, how to adapt.
Life is built on experience, and we all make mistakes and stuff like that, but manufacturers, and certainly dealing with sales teams and everything like that, if they're not responsive to you, and there's plenty of other people that you can go to now and see.
You are working with people.
You're working
with the manufacturer.
Yeah, exactly that. You know, and I've got good relationships with many manufacturers, many installers, and all sorts of things like that. I can be brutal. I like to call things out when I see things as being wrong, or whatever, and I don't really care who I upset with it, because I just don't think, I think it's and I'm happy to take it on the chin as well. If I've got something wrong, then yeah, please tell me, and that's, you know, I'm happy for that. But I like to challenge the status quo. I like to try and find manufacturers that are not just trying to sell you a product
or box movers.
They're trying to sell you a service.
And solutions.
If they come across and they sell you solutions and they sell you support, and I mean, I'm working. I'm not going to mention any companies' names at the minute, but I'm working with a couple of companies at the moment, which I have to say makes me want to get up to work in the morning, because they're being really helpful with everything that I've asked. Nothing is too much trouble, and that's brilliant. And especially in this day and age now, when everyone's trying to fight for, you know, prices are sky high on lots of things. You know, you need that service to have the backup. I mean, you know, you take, for argument's sake, an installer of Panasonic heat pumps. The only reason they're going to be fitting Panasonic heat pumps is two things. One, they understand the control systems, and you know, pretty much the vapor compression technology is the same wherever you go. They're going to buy it because they like the unit, they like the control system of it, they understand how to do it because they've done the training course for it, and then the main one at the end of it is they get support. Yeah. That's it. You get all of those ticked. That's why, you know, you finding very, very, very few people now are installing multiple brands of heat pumps or boilers or anything. They'll find something they want, something they get support, and they'll stick with it. Yeah, and that's it. Yeah,
this makes sense. Thank you, Rob, and it's good to be here.
Yeah, it's good. I enjoy.
Yeah, I like this conversation. I like your country. So
it's a beautiful country. Yeah.
Thank you, Rob. Thank you, everyone, for watching. I hope you learned something really good from our discussion. Check our other videos from UK trip and follow us for more content. See you.